In this video, I will talk about a one-tailed hypothesis test. So let's jump right into an example. A phone industry manager thinks that customers' monthly cell phone bills have increased and now average over $52 per month. The company wishes to test this claim. We'll assume a normal population. So I'm going to go ahead and set up the hypothesis test. My null hypothesis is that the mean is equal to $52, but the manager claims it's more than 52. So my alternative hypothesis would be mu is greater than 52. Another way that you can write this is, remember, the equal sign is always in the null hypothesis. So you can also write it like this. Let's see, get my pen out. Oops. You can write the null hypothesis. Sorry. There we go. Had to get the pen out. As this: less than or equal to, as long as you have an equal to. But for the most part, you can just use equal to in the null hypothesis. Doesn't matter if you have a less than or greater than in it, as long as you have equal to. The alternative hypothesis cannot have equal to. So in this case, we want to test to see whether or not it has increased, so it's greater than 52. So this is a one-tailed test. Our rejection region will be in the right tail, since this is a right tail test. The reason why it's a right tail test is because your alternative hypothesis has greater than. So it's pointing to the right. Alright, so we need to figure out the t-value that will separate the rejection region from the non-rejection region. So in this case, the area here will be our level of significance. We're going to test this at a 0.1 level of significance, and we're going to draw a sample size of 25. So since we know that the degrees of freedom would be n minus 1. So in this case, it's 25 minus 1, which is 24. So that's my degrees of freedom, and we're looking for the upper tail of 0.1. So let's go ahead and go to our table. We're looking for 24, and we're looking for zero point 0.1. So this is 0.1 here in the upper tail, and so it meets here, 1.3178. Okay, or we can just round it. It was 1.318. See, let me go back. So yeah, we can round that. All right, so that's the t-value that separates the regions. And now we have to calculate our t-stat. So we'll reject this null hypothesis if our t-stat falls in this blue area, or if it's greater than 1.318. So let's say we went ahead and drew our sample of 25. We found out that the sample mean is 53.1, $53.10, and our standard deviation is 10. So I'm going to plug everything back into the equation for t-stat, our t-statistic, and I get 0.55. Okay? So as you can see, my t-statistic does not fall within the rejection region. It's in the non-rejection region. So we do not reject the null hypothesis. So that means we do not have sufficient evidence to say that the mean bill is over $52. We do not have enough evidence to support this claim here. We don't have enough evidence for that. Okay. We can also do it with the p-value approach. So once again, I'm going to show you how to do this in StatCrunch, as well as along with my template. So we're going to go to stat, t-stat, one sample with summary. And we're going to type in our information. The sample mean was 53.1 with a standard deviation of 10 and a sample size of 25. Our hypothesis test, we were looking at 52. As you can see, it populated in our alternative hypothesis as well, but we're going to change this not equal to greater than. Okay, so it looks just like the test that we did on paper. So we're going to hit compute, and we get our information. As you can see, our t-statistic calculated out to be 0.55. That's the same number we got when we did it by hand. And we got a p-value of 0.2937. So if you watched my previous video, um, remember the saying, if p is high, the null must fly. If p is low, the null must go. So in this case, our p-value is 0.2937. We compare that with our level of significance, and it will be higher than our level of significance. As you can see, if I go back, we tested this at zero point 0.1. So my p-value is 0.2937. This is higher than zero point 0.1. So if the p is high, the null must fly. That means you do not reject the null hypothesis. That's the same conclusion that we got here when we did it with the t statistic. Now let's go ahead and use my template. I'm going to go ahead and plug in the information in the blue sections, in the blue cells. Standard deviation is 10 degrees of, the sample size is 25, and we're testing 52. Put 52 in both boxes. So when you do hypothesis tests, the values would be the same. So I got 52 in the null, 52 in the alternative. Those will never be different. All right, so this time we're doing greater than. So I'm going to click on the box that has for the alternative hypothesis, and I can change it to greater than. And I'm testing this at 0.1. So don't forget to put in your level of significance. As you can see, my test statistic came up, which we calculated it to be 0.55. My critical value also came up, is 1.3178. We can just round that to 1.318, and that's what we got when we looked at the table. We got that as the cutoff value. And my p-value is 0.2937. That's what we said we got when we did it with StatCrunch. And I got my conclusion. Since my p-value is greater than 0.1, the level of significance, we fail to reject the null hypothesis. We do not reject. All right, let's do another example. In 1991, the average interest rate charged by U.S. credit card issuers was 18.8%. Since that time, there has been a proliferation of new credit cards affiliated with retail stores, oil companies, alumni association, professional sports teams, and so on. A financial officer wishes to study whether the increased competition in the credit card business has reduced interest rates. The officer selects 15 credit cards and obtains the following information. He shows that X bar is equal to 16.8267. The standard deviation is 1.5378, and he tested it at a level of significance of 0.01. I'm going to change this 18.8 to just 18 because that's what I put in my example when I did it. Okay, so whatever's in the problem will be what you will test. But in this case, I don't know where I got 18.8 from. I probably just mistyped, so just put 18. All right, so our null hypothesis is that the mean is equal to 18. This financial officer wants to see whether or not it has decreased or reduced the interest rate. So I'm going to put the mu is less than 18. The mean is less than 18%, and if we test this and find that to be true, then it will be sufficient evidence exists to support the financial officer's claim. Okay, so this is also a one-tailed test. This is going to be a left-tailed test because we're doing a less than. If you look at our alternative hypothesis, is the inequality is less than. So this is a left-tailed test, and this green spot will be our rejection region. So this is what happens if you do it by hand. Your degrees of freedom, since you have 15 as the sample size, your degrees of freedom will be 14. And we're testing that at a 0.01. So I got my critical value to be negative 2.6245. Anything that's on the left tail will have a negative critical value. So how did I get that? You're going to go back to your table, and let me go ahead and erase this. We're going to go to 14 for my degrees of freedom, and we're going to go to 0.01 in the upper left. in the upper tail. So 0.01 and 14. So if we go here and go down here, this is where they meet up, 2.6245. Okay, but that is going to be, sorry, that's going to be negative. And that's what we have, negative 2.6245. And then we're going to calculate our test statistic. So our t-stat is going to be the mean, which they said was 16.8267. That's the sample mean, minus mu, which is 18, divided by 1.5378, all over the square root of 15, our sample size. And when I calculated that out, I got a negative 2.954. As you can see, negative 2.954 falls within the rejection region. So that means we have to reject the null hypothesis. Since we reject the null hypothesis, there's enough evidence to support the claim that the mean interest rate is less than 18%. We have enough evidence to support this claim here. Okay, so let's go ahead and do this in StatCrunch. Go to Stat, T-Stat, one sample with summary, and I'm going to put in my information. My mean is 16.8267. This is my sample mean. My standard deviation is 1.5378, and my sample size is 15. Here we tested the mean 18, and we want it less than. Okay, so I hit compute, and everything comes up. T-stat is negative 2.954, which is what we did when we did it by hand. But let's look at the p-value, because this is the p-value approach. The p-value is 0.0052. Okay, so if we go back here, p-value is 0.0052. So, and we're testing at a level of significance of 0.01. So if the p is low, the null must go. Our p-value is less than, our level of significance. So we must reject the null. If the p is low, the null must go. So you reject h naught. And that's what we concluded when we did it with the critical values and the t-values. Now let's go ahead and use my template. I'm going to put in all of my information in here. My standard deviation 1.5378, and we had 15 for the sample size, and this was 18. This is 18. And this time I'm going to change the inequality in the alternative hypothesis to less than, and I'm going to change my level of significance to 0.01. So you make sure you fill out everything in the blue boxes. As you can see, I got my test statistic again, negative 2.95498. I got the critical value, which we calculated with the table, so that should match up. And I got my p-value, 0.0052. And I believe that's what we got here. Yes, that's what we got here. So we go back, and my conclusion came up. Since the p-value, 0.0052, is less than the level of significance, we reject the null hypothesis. Okay, that's the end of this lecture.